this is Math 130, 4.7. So for the previous video, let's look at what we had discussed. Recall for the function f of x equals x squared plus 1 on the interval from 0 to 2, that's from 0 to 2, the area we integrate from 0 to 2 of this function, and that's how we find the area, which is everything underneath the curve. Okay, we had talked about doing the left rectangular approximation. So the area approximates the L4, where we split this up into 4 equal subdivisions. There are 1, 2, 3, 4. And then we took left rectangles, so we started from the left. Think of it this way. We went over here, so we're taking this times this to find this. Then we go to this point. And we take this times this to find this portion. And then we take this point here, this times this to find this portion. And then this point here, this times this to find this portion. Okay, so notice that this was 0.5, this point is f of 0.5, and so forth. Okay, so what we did was, we said delta x times f of 0 starting from the left, plus f of 0.5, f of 1, f of 1.5, because that's that point right there, this distance times that. And it came out to 3.75. Well, we can also go the other way. We have right rectangle approximation. Right rectangle approximation. So let's draw the same picture and see how this works. Okay, 1, 2, split it up into 4 equal parts. 0 and 1, and draw our little picture. Oops. All right. Okay, so we're going to go from the right now. You can think of it this way. This is f of 2. And we're going to go this way. So we're looking at this times this equals this. Okay, then we take this one, like a rectangle, and we're taking this length times that width. Okay. Then we take this one, which is f of 1, bring it over, and this times this. And then the last one, bring it over, f of 0.5 times 0. Okay, so this one we're missing some spaces, and here we're overestimating. We're going over it. So let's do this. A is approximately R4. In this case, which is going to be delta x as well, 0.5. All right. And now, where before we started at 0 because we were going left, this times this, we're no longer going this times this, we're going the 0.5 times that. So we're looking at f of 0.5. Okay. Then we're looking at f of 1. F of 1.5, and then f of 2, because we're going f of 2, this times that, plus f of 2. Okay? So when we add those up, we get 0.5 times f of 0.5 is 1.25. F of 1, we put that in there, 1 plus 1 is 2. F of 1.5, put 1.5 in there, and we get 3.25. And the last one is f of 2. We put a 2 in there, and we get 5. Okay, and when we calculate that out, we get 5.75. All right, so the area under the curve here is 3.75. and it underestimates what it is, and the area here is 5.75, and it overestimates. What if we took the average? That might be better, right? To take the average. Let me put this average. Okay. So we're going to take the average of the left and the right. So the left is 3.75. The right is 5.75. We divide that by 2. And we see that equals 4.75. So that's a more accurate estimate of the area under the curve. Okay? All right, let's keep going. I forgot to mention, what you're looking at, these sums are called Riemann sums. So the sums that we were just working on are Riemann sums. Now remember, everyone back then, they didn't have calculators. They didn't have computers. So they had to figure this stuff out on their own by estimating. So that's one method, the Riemann method, using Riemann sums. Okay, so now delta x, we've just been talking about a lot. Official definition of delta x is we take b minus a divided by n, where n equals the number of subdivisions. The number of subdivisions. In our case, it was 4. Okay? All right, now remember, this is talking about where we're looking at from a to b of f of x dx. All right? So b minus a divided by how many subdivisions is going to be our delta x. Okay? All right, so in our example that we've been using, our delta x was 2 minus 0, because we were going from 0 to 2. All right? And we decided we wanted to split up into 4 equal parts. So we divided by that 4, and that's how we got 0.5. Okay, so let's do a little example. What is delta x? If we split the integral from 0 to 2 into 8 subdivisions. Okay, so delta x equals 2 minus 0 over 8, which is 2 over 8 is 1/4, 0.25. So you'll need to know how to do that to do your homework, to find your different delta x. Okay, so we're going to do different methods because, like I said, people sat around using their brain because they didn't have little calculators or computers to do it. So here's one way called the midpoint rule. These are all different ways of estimating the area under the curve. Okay, so let's draw this picture. Same one we've been using all along. I figure it's easier if I keep giving you the same example. 0.5, 1.5, 0, 1, and draw a curve. Okay. Midpoint rule sounds just about what you're thinking. We're going to take this rectangle out here, okay? And instead of calculating all of this area, we would take this point right here, which is in between those 2 points, right? And we'll figure out the width times that height. So the width here is 0.5 times that height. Now how do we find that height? Let's go ahead and draw the pictures and I'll show you in a minute how we find those. Okay, so we're looking for the midpoint in between each of these so that we can use this length in between each of them to calculate those little rectangles. Okay, once again, we're going from 0 to 2 of x squared plus 1 dx. Okay, so the midpoint, let's take the midpoint here. To find the midpoint, we take the first point, we add it to 0.5, and we divide it by 2. That's 0.25. So that would be 0.25 right there. Okay, let's find the midpoint of here. 0.5 plus 1 divided by 2 is 0.75. That's the midpoint there. And that makes sense when you look at it, 0.5, 1, 0.75. So let's keep going. The midpoint here, we start at 1, add it to 1.5, divided by 2, and we get 1.25. The midpoint here, we have 1.5 plus 2 divided by 2, and we get 1.75. Okay, so instead of using an L for the left or an R for the right, we're going to use an M for the midpoint, and we're going to split it up into 4 subdivisions, equal subdivisions, just like we have done. So we know our delta X is going to be 0.5. Okay. Now how we do the midpoint is we do F of the midpoint. So F of the midpoint is 0.25. So when you think about it, just looking at this right here, we're taking this point, this length right here, and we're timesing it by that width. So it's really taking the average by looking at the midpoints there. All right, so that's for the first one. Then we would go on to the second one, F of 0.75, and then plus F of 1.25 plus F of 1.75. Add those up, multiply them by 0.5. Okay. So when we put 0.25 into our function, we get 1.0625. Okay? And then when we put 0.75 into our function, we get 1.5625. And then when we put 1.25 into our function, we get 2.5625. Running out of room here. And then when we put 1.75, which is the midpoint right there, into our function right here, we would be getting 4.0625. So when you add all those together, all of this, we end up with 9.25. And so our area is 4.625. Okay? Which shows we're getting closer. I like this one, this method. It seems to work. Okay, let's keep going. We have 2 more rules to go over. This next rule is called the trapezoidal rule. Trapezoidal rule. Okay, so kind of what you expected. I'm not going to draw the pictures out, but using trapezoids to figure out the area under the curve instead of rectangles. Okay, trapezoidal rule. Okay, and again, we're going from the integral of a to b, f of x dx. Okay, and here's the formula. I'm just going to give it right to you. T sub n equals delta x. Okay, this is a little bit different than you're used to. We're going to do f of a divided by 2. Then we're going to add that to f of x sub 1, which is our first subdivision. All right, plus f of x sub 2, dot, 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 until we get towards the end. I'm going to call it f of x and sub n minus 1. We're getting towards the last one. And the very last one, we do f of b over 2. Okay, so let's do that to our function that we've been using. I'll just draw a picture, make it easier for us to see. We don't always need a picture, and we'll get to that as we start working some more problems. But as you're first learning, I think a picture really helps. Okay, so we're going to use T of 4, just like we've been separating. We know our delta x is 0.5. So this is the part that's new for us. F of a over 2, well, a is 0. F of 0, remember we've been doing x squared plus 1 is our function. So we put a 0 in there, and we get 1 over 2. That's f of 0 over 2. Now we're going to put 0.5 in there. If we put 0.5 in there, we have 1.25. If we put a 1 in there, we have 2. If we put a 1.5 in there, we have 3.25. And then this one considers the last one, f of b, which is 2. And if we put a 2 in there, that's 4 plus 1 is 5. We get 5 over 2. Okay? So when we add all this up, we have 0.5 times all of this is 9.5, which equals 4.75. Okay? So now I'd like you to do a problem with me. Here's an example of a different type of problem using the trapezoidal rule. So use, I'm just going to say the trap rule to find T4 for, we're going to integrate from 1 to 3. So this is different than what you've been saying, an x squared dx. So we're no longer using this function, we're going to use this function instead. And this time we're not going to use a picture. We're just going to apply it to our formula. So we have t sub 4 equals our delta x. Now our delta x is going to be from 1 to 3. So we'll go off to the side. Delta x equals, we're going from 1 to 3. So it's b minus a, 3 minus 1 over 4, which is 2 over 4, which in this case just happens to be 0.5 again. All right? So we have 0.5. All right? Now we have to use our formula. F of a over 2. F of a, if we put a 1 in there, we get 1, and we're going to put that over 2. Okay? Now what's our next one? Well, we're dealing with delta 5, so we're going to add 0.5 to 1. So we're looking at f of 1.5. All right, so we add 0.5 to there. Now to get to our next one, we're going to add 0.5 to this, and we'll get 2. And then we'll keep going till we get to the end, plus f of 2, 0.5. And now we're at the end. If we add 0.5 to that, we get 3. So we're at the end. And according to the rule, we're going to do f of 3. Now what is f of 3? If we put a 3 in there, we get 9. So f of 3 is going to be 9 divided by 2. Okay? So let's continue with this problem. We have 1/2 f of 1.5. We would put 1.5 in there and square it. And when we do, we get 2.25. F of 2 means we put 2 in there and square it, and we get 4. F of 2.5 means we put 2.5 in there and square it, and we get 6.25. And then we have 9 divided by 2 plus 4.5. All right, so when we add all that together, multiply it by 0.5, we get 8.75. All right. One more rule to show you and we're done. Now this next rule, I really like it because it seems to be the most accurate, but it's kind of, I guess I'll say, trippy. Just know this. You're not math majors. You don't need to know completely how it works. You can just utilize it. You're going to stand on the shoulders of the geniuses that came before you and came up with it. Let's put it that way. Okay, so we're going to integrate from a to b, again, f of x dx. So this is another way of approximating, but this way is really a really good one. This is Simpson's rule. Simpson's rule. Okay, to use Simpson's rule when we're dealing with the interval that we're working on, it needs to be, the subdivisions need to be even. So subdivisions, we need an even number. Like we can't have 5 subdivisions. We need 4 or 6 or 2, even number. Okay, so here is the Simpson's rule, and it's you're gonna go, what? Don't worry about it. I'll give you an example. So Simpson's rule is b minus a over, instead of n, it's gonna be 3 times n. All right, why? You don't need to know that at this level. You just know how to apply it. So here's this rule: f of a plus 4 times f of x sub 1 plus 2 times f of x sub 2. And guess what we would do from there? We'd go 4, 2, 4, 2, 4, 2 until we got to the n. So I'm going to say plus dot, 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 plus, and we're getting towards the end. So 4, 2, 4, 2, wherever we go till we get there. The last one prior to that would be a 4, f of x of n minus 1. And then at the very, very end will be f of b. So this one includes both endpoints. All right? So let's try it. Let's try it with the example we had. We're going to integrate from 0 to 2, x squared plus 1 dx. Okay. So s of 4 equals 2 minus 0 over 3 times 4. Okay, and we're going to multiply that by f of a. Now a is 0. If we put a 0 in there, we're going to get 1. Plus 4 times f of x sub 1. f of x sub 1 is going to be 0.5. Remember we did this last time? So I'm going to say 4 times f of 0.5. Because our delta x, even though we're looking at this which is not delta x, our delta x is 0.5. So we're going to keep adding 0.5 to each previous number. And we're going to be alternating these 4's and 2's. So we have 2 times f of 1 plus 4 times f of 1.5. And now we're going all the way to 2, right? So we're going to stop there and go on and add the endpoint, like we said before. F of b, we put in 2 in there, square it, we get 5. Okay, bring this over here. So this becomes 2 over 12. We have 1 plus 4 times f of 0.5 is 1.25. Plus 2 times f of 1 is 2. Plus 4 times f of 1.5 is 3.25. Plus 5. Okay? And when we do all this, we get 1/6 times 28, which equals 4.67 if we round off. Okay. Now this is really cool because remember in the very beginning in the first video, I had said to you we can find exactly what the interval is of x squared plus 1 dx. And it equals 4 2/3. Well, look at that. Look how close that is. Really cool. I'm going to put a happy face for